Hi everyone, I'm Seth Kimbrell. I'm a PhD student at Montana State University, and my talk is on the diverse morphologies of dwarf galaxies hosting optically selected AGNs. And this talk accompanies a paper which has been submitted to AppJ. So the question is, why study these dwarf galaxies? Well, dwarfs which host AGNs give us a chance to investigate the formation mechanisms of supermassive black holes. Because we want to know, how did black holes grow to be as massive as billions of solar masses relatively quickly within a gigayear of the Big Bang? The difficulty is, with current technology, we can't probe the seed black holes at those very, very high redshifts. Instead, dwarfs which host massive black holes give us a chance to study black holes which haven't grown to be supermassive. Now, dwarf galaxies come in a variety of types and morphologies. So any attempt to constrain the occupation fraction of black holes in low-mass galaxies needs to have answers to the questions, which of these types and morphologies have black holes, and what are the properties of the smallest galaxies which host black holes? To that end, we present Hubble infrared imaging at 1.1 microns of a subset of AGN hosting dwarf galaxies from Rines et al. 2013, who used Sloan spectroscopy to optically select dwarf galaxies which host AGN. Our galaxies were imaged in an HST SNAP program. They were selected to be in the AGN or composite regions of the O3 over H beta versus N2 over H alpha diagnostic on the left. They were also chosen to be in the Seifert region of the O3 over H beta versus S2 over H alpha diagnostic on the right. So these are the best candidates we have from the Rines et al. Sample to be dwarf galaxies which host AGNs. A note on the color scheme here. The blue and purple dots show in the diagnostic on the right where the AGN galaxies and where the composite galaxies fall, respectively. Here we present some properties of our sample of galaxies compared to the Rines et al. Sample as a whole, with median values shown in the vertical dashed lines. Our sample of galaxies are shown in green, the Rines et al. Sample are shown in gray. So this is to show that our sample is representative of the overall Rines et al. Sample. An interesting note here is in the stellar mass plot in the top left, the median stellar mass is comparable to that of the Large Magellanic Cloud. So those are the sort of masses that we're working with here. There were 41 dwarf galaxies in our sample. 35 of them had regular morphologies and were able to be modeled using the galaxy fitting software GalFit. In our modeling, we include a PSF, an exponential disk, and an inner Sirsic component, which we loosely are going to refer to as the bulge or the pseudo-bulge. So here I'm showing 3 examples from our sample to illustrate the range of morphologies that we're seeing here. So on top, we see a disky galaxy, which has a very compact inner component there. In the middle, we have a galaxy with a bulge or pseudo-bulge, as well as an exponential disk. And at the bottom, we have a galaxy which is a pure bulge, pseudo-bulge galaxy with no detectable disk at all. So the big point here is that there is a wide diversity in the morphologies of these AGN hosts. What we're seeing in our dwarf galaxies is that they tend to be disk-dominated with a mean bulge to total light ratio of 0.21, but there is a wide range there. Some of the galaxies have a pretty even split between the bulge and the disk, and then some are very bulge dominant. In addition, 4 were best fit as pure disks with no detectable inner component, and 6 were best fit as pure bulge, pseudo-bulge galaxies with no detectable disk component. So that was 35 galaxies in our sample. The other 6 were too irregular to model, and we're showing those 6 here, along with the 3 arcsecond diameter SDSS fiber shown in the black circle. 3 of our irregular galaxies resemble Magellanic type dwarf irregulars, while 2 show signs of interactions. And in the bottom left there, you see these really pretty elongated tidal tails. So to wrap up, we have found dwarf galaxies hosting optically selected AGNs exhibiting a wide range of properties and morphologies. This is important to remember, as any study which attempts to constrain the black hole occupation fraction in low mass galaxies in an effort to probe formation channels needs to account for this variety in morphology, because any search which focuses on a particular type of galaxy, like early types, may have skewed results for the occupation fraction of black holes. Thank you.